And next the next subtopic that we cover will be universal statements. Alright, so universal statement will be statements in general, universally true. So example, let's say I have a statement: all fishes can swim. Alright, so we have a statement like that. Okay, you are asked to you probably be asked to translate this into symbolic representation. Now this is a all type of statement. Okay, the other type of statements that you probably encounter would be some fishes can swim, and yet another type would be no. Okay, so let's say no fishes have legs. Right. Okay, so let's try to translate all these statements into a symbolic representation. Okay, the first type of statement, which is the all type of statements, okay, there are actually two ways to represent it. Okay, first way is to make use of a predicate and a domain. Okay, so we have this symbol for all x. Okay, this symbol actually means for all. X is just think of it as a placeholder. So for all x, okay, there is a member of set F. Okay, this is a member of. So for all x that belongs to this group F, okay, Sx. Okay, on their own they are quite meaningless now, because we have not defined what F, okay, or predicate Sx represents. So in order for the translation to make sense to people, you have to define what each of them, each of the domain and the predicate represents. So we put down let F be set of fishes. Okay, and we put down let Sx be the statement x can swim. Alright, then it will make sense. Okay, so it will mean that our symbol means that for all x that belongs to F, so everything that belongs to set of fishes, in other words all fishes, okay, Sx, x can swim. So for every x that belongs to set F, all the fishes can swim. Right? So this is the first way to translate. Okay, the second method of translating the all fishes can swim, all type of statement, is to make use of two predicates instead of one. So this is method number one. Okay, now I'll show you another method. Okay, the other method is we will make use of two predicates instead of just a single predicate, and we will translate this statement into a conditional statement. Alright, so the second predicate that you will need, okay, will be x is a fish. Okay, so we translate the same statement above into for all x, if x is a fish, then x can swim. So this is the second translation, okay, for the same statement. Okay, can you see what's the difference? The difference is, okay, we have in the first translation we have a domain F, okay, domain F, which is a set of fishes. Okay, in our second translation we don't make use of domain, instead we make use of two predicates, fx and sx. Okay, fx means x is a fish, and sx means x can swim. So for all x, if x is a fish, then x can swim, which actually captures the same meaning as the statement here, all fishes can swim. Right? Of course, under normal circumstances we try to avoid using same letters because it's a bit confusing. And to tell you a bit about the syntax, predicates, we expect it to be an uppercase letter, so you need to have uppercase S and uppercase F in this case. Okay, moving on to the second type of statement. Second type of statement will be some fishes can swim. So some is not all, it's not no. Okay, it's somewhere in between. You can think of this as a spectrum. Okay, over here we say, oh, none of them have will do certain things. Over here we say, okay, all of them will have some characteristics, and the sum is actually in between. Okay, So for some type of statement, we will use this symbol, which actually represents there exists. Okay, so there exists x belongs to f. Okay, some features. We will reuse what we have defined here. Okay, such that, okay, for the there exists, okay, we have this separator which is read as such that. Okay, what is it they want to tell people about the features? They can swim, right? So it is SX. So this is the translation. Okay, the last type of statement that we want to do will be the no type of statement. No fishes have legs. So for there's no symbol for no. Okay, we have the or statement, the universal quantifier. We have the there exists, which is the existential quantifier, but we do not have a quantifier for no. Okay, so you have to on your own translate this into another form. So all fishes have legs. We actually translate this statement into all fishes don't have legs. Okay, so all do not. Right. Okay, so this is the way to handle. For no type of statement, we have to change it into all are not, or all have not, have no legs. Okay, so then after that we can translate this sentence quite easily using either of this method. Okay, let's use the conditional one. So for all x, okay, fx implies, okay, don't have legs, right? Okay, I use let's say lx to represent have no legs. So of course, don't forget you need to define what lx means. So in our case, what does lx means? Don't have legs, right? X has no legs. Okay, so you need to write this down for the complete answer. Okay, so having talked about the translation, okay, we can then go on to talk about the arguments. Okay, some